relationships between all these functions and how they were called. There's another view here. If you look at the statistics table now, before it was just all flat, but now it's going to be in a tree structure, so it starts with main. And if you click over here, then you see everything that's called directly from main. And again, it's color-coded, so you can see, you can home in on the hotspots in the code and see where the actual, where the end, you know, where is the exclusive time spent in each of these. So you can see how they're called and get the interactions there. And that's useful when you want to create, if you wanted to create a phase profile, or if you wanted to drill down on what exactly, which of the many functions that are being called is causing the issues there. And then you can sort these based on how many times they were called. So if you you can do you can create a selective instrumentation file automatically, but if it doesn't catch everything, or if you want to check that it's catching everything you think it should, you can go to this list and look at how many times these things are called. And if you see a function that's called more than you'd like, or if you know the function is not important, or you can check that. You can add it to, you can exclude it with that selective instrumentation file. Okay. So I showed you how to, I showed you the selective instrumentation file and how you can use that to get a phase profile by adding that static phase line in between the begin and end instrument section. So let's see. Do we have questions at this point about anything I've talked about so far, or is there something specifically you'd like me to demonstrate? I've got a couple more things, but I'd like to see if there's anything that you're missing that I can help with.
Hey, Phil.
Yes.
Yeah. This is Kent. And in /temp, I put an example of the matrix multiply that they use, and it's a tar file, and it has a source me file in there that we use in our training, and I updated it for the latest and greatest version that you requested we put out there, which is the 2.19.2. And so somebody suggested that I tell people about that, so that if they're using Ranger and they just want to really use what's on there now in the directories and the modules, they can go ahead and get a start on it that way. And so that's on login 4 and login 3, any one that you log in. There's a world readable file in /temp called cow_example. I'm not sure if it has the S on it, .tar. And if you untar that, you'll have it in that directory where you're residing. You'll have a little matrix multiply Fortran file, a C file, a make file, and a source me file, and a file that has the instructions there. And it's relatively simple to use. So if people want to get started using the ones on Ranger instead of the ones in your account, that's fine. But I highly suggest they use your files, because you provide a lot more information, a lot more details, and you've done a great job on providing information about Tau on these systems. It's a great job. Thank you. But
Thanks,
I
Ken.
just wanted to point out, if you want.
Sure.
Okay.
And let me also point out too is you could use you can replace my paths, especially if for some reason you're still having an issue. But please let me know if you are. But this basically I just didn't get a chance to replace my paths there. But if you do module avail Tau on Ranger, where am I? Not on Ranger. if you do module avail tau on Ranger and then do module show this latest version of tau, then you can pull out of that the directories to the world readable installation on Ranger there. So if you look at the tac-tau bin or the tac-tau lib, so those would be the two directories that you need. So you could replace those in the examples I gave you on Ranger if you want to work with those, or if it's still causing problems. But either way, you can use you can use this installation on Ranger with my examples or with the example that Kent just mentioned that he's provided for us there. So that's great. But let me know if you do continue to have any trouble with that. Okay, so feel free to, if anything about what I just went through wasn't clear, then feel free to shoot a question my way. Why don't we go ahead and look at the hardware counters here. So this is fairly straightforward. Now, I think to do this right, as I mentioned, if you wanted to use the PAPI avail, then I think that you need to run it on the compute node. But you can load PAPI here, and I think so. If I'm right now I'm on a login node. Oh yeah, so it does give me an error. So yeah, so you need to run this on the login node or on the compute node to get the output from that PAPI avail. So I think you'd have to redirect that to a file, since there's not, at least on Ranger, because there's not an interactive session that we can get directly. But so you can look at the output on that on Ranger. Let me.
So if they untar that file I mentioned, it has a printout of that. We provide that as a printout.
Oh, great. Okay. So so in that /temp directory, in that example, if you want to see the output of PAPI avail on Ranger, then it's got that in there. So that's great. Let's see if I can. See if that will start. So so anyway, so from that list that you got off the compute node, then you would grab the names, or from the printout that is provided in that /temp in that tarball that Kent mentioned. You can get the names of these different hardware counters, and so then since we've already compiled this with a make file that has PAPI in it, we don't need to recompile the code if we want to get the hardware counters. We would just need to add to our list of environment variables this tau_metrics. And then we would do a comma or a colon delimited list of those. And so let's see. Make sure I get these right. Yeah, so, all right, so we can So we set a list like that before we run the job. And we make sure PAPI is loaded there. And so this will give us a profile with these counters measured. So we'll just let that go. But that's how you get the counters. So let's see here. So I think I showed you how you can look quickly at the load imbalance by breaking these down. And you can look at how the different functions balance across the nodes. So I'm going to show you now how to look at so if you want to do a serial, so look for how each individual function is scaling, and to do that within, say, like a phase profile. So if you do a phase profile, I've got an example here. So in this examples slash unres, you see there's a number of different runs from 2 to 32 cores. So if you want to try and follow along with this, you can download these to a directory. So just save link as, and then I think I've already got these here. So you save each one of these in a file, and you want to save them all, because if you just click on them, it opens up a whole new instance of Paraprof. And what I'm going to show you is how you can put these all together across different runs into a single comparison, and also use the phase. So this corresponds to it's a little bit involved, but it's not too bad. But there's instructions on this here. Okay. So on this slide, it's number 55 that I presented before, is sort of the step-by-step of what I'm about to show you. And this is, I labeled it detecting serial bottlenecks. So you're going to compare the scaling in a section of code that you're interested in. So you've defined a phase, like I've showed you. And so now we're going to, so now I'm just going to go, if you want to try and follow along, then download those files I showed you. And I'm going to go ahead and show you how to do what's described here. Let's go to that open directory. Okay. So I'm going to double click on the first one. I'm going to start with the lowest processor count and go in order, because that makes it easier to look at. So in this run, so you can see these look like regular functions, but if you scroll over this one, you see it's labeled with my label phaseMD, where I pulled out the loop that I was interested in out of the code by using that phase profiling through the selective instrumentation file. So, so what I'm going to do is I want to get rid of anything that's not in that phase for the purposes of looking at and comparing the data. And so I'm going to go to the Windows tab up here and go down to Function Legend. And this is described step by step on that slide.